Module 1, Section 2, and we're going to concentrate in this video on Objective 5. Objective 5 says identify and apply commutative property of addition. I would have said the commutative property of addition, but that's all right. So the commutative property, okay? So first of all, let's talk about that word. Okay, commutative. First of all, there's no N in it. It's not commutative, okay? It's commutative. So that would be like commuting to work. So if you commute, it means you go to work one direction. At the end of the day, you come home and get where you left. Okay, so it's the same distance both ways. You go one direction at the beginning of the day, and you go the other direction at the end of the day. You're commuting. Okay, so the commutative property is talking about the change of direction. Okay, and we'll see what that means here in these problems. So look at the pairs of sums below. What do you notice? What do you wonder? Okay, now when we say the pairs of sums, it means these two, and these two, and these two. Those are the pairs. Okay, so the top row, we have 2 plus 3 equals 5, and 3 plus 2 equals 5. So what did they do? 2 plus 3 is in that order, and over here, it went backwards. 3 plus 2. So like 2 plus 3, 3 plus 2. On the second row, 7 plus 4 is 11. 4 plus 7 is 11. 7 plus 4, 4 plus 7, right? So it's just reversing the order. And the last one, 100 plus 30 is 130. 30 plus 100 is 130. So 100 plus 30, 30 plus 100. You're commuting the numbers, or the add-ins. Remember that word? Okay, so these two numbers are the add-ins, because they're the two numbers that you add in a sum. So the add-ins change order. That's what the commutative property is. Okay. And here it is written as a sentence, as an equation or a formula, and then there's an example. Okay, so changing the order of the add-ins, A and B, does not change their sum. Okay, so the way that we wrote it on the past pages, we said, for example, 3 plus 5 was 8, and 5 plus 3 is 8. So it's just showing you that you reverse the order and you get the same answer. But because they are equal to 8, you can say they are equal to each other, like this. Okay, so no matter what two numbers you start with, so 4 plus 9, that's going to equal 9 plus 4. 10 plus 37 is equal to 37 plus 10. If you figured this side out, you get 47. You figured this side out, you get 47. And they are equal. Okay, so that's the commutative property. Now let's see how we're going to use it. I forgot, we're going to add one extra page in here that is not in your notes. Okay, subtraction. Is subtraction commutative? I know this is not the subtraction objective, but we're talking about the identities right now, so I wanted to throw that in really quickly. So is there a subtractive identity? So it needs to work in either position, right? So when we did it with addition, I'm going to use 45 again. We had 45 add 0 was 45, and we had 0 add 45 was 45, right? The 0 could be first or second, it didn't matter. So is there a number we can put here so that 45 minus something equals 45? Sure, it could be 0. Okay, what about the second one? Is 0 minus 45 equal to 45? And it isn't. If you start with 0 of something and you subtract 45 from it, so let's say you didn't have any money and you spent $45 on something, you wouldn't all of a sudden have $45. You would be in the hole $45, wouldn't you? I know that's talking about negatives and we haven't gotten to that. But the idea is, it is not equal, is it? So there is no subtraction commutative property. Okay? It doesn't exist because you can't put 0 in both places. You can only put it in one. And the reason we needed that is for the third box. You can see there's a subtract in it. Okay, so let's go up here to the first box first. Okay, so 34 plus 17. Using the commutative property, rewrite the statement, and if not possible, write NA for not applicable. Okay, so all they did was reversed it, put the 17 first and the 34 second. You changed the order of the sum. Okay, I would say the add-ins. Yeah, the sum changed order, but to do that, you switched the add-ins, right? You switched the two numbers you're adding together. Okay, so 29 add 8 is now 8 plus 29. You change the order of the add-ins. And the last one, 72 minus 56. You cannot reverse it, can you? Because 56 minus 72 is not the same. Subtraction is not commutative, so you don't want that as an answer. You want NA. It's not applicable because there is no subtraction commutative property. Okay, so go ahead and try yours. And here we go. So, because addition is commutative, you could rewrite this, changing the order of the add-ins, 24 add 45. And that's it. That's all you have to do. Doesn't say to solve it, just says to rewrite it. Okay, 75 add 91 is the same thing as 91 add 75. Totally easy. Now on this last one, can I reverse it? Is this the same as this? No, it's not. Because on this side, you have a big number subtract a small number, so that's going to be okay. And on this side, you have a small one minus a big one, so that's going to be negative. And like I said before, we'll get into that later with the positives and negatives, but for right now, just recognize that if this is a subtract problem, then this is not applicable because there is no subtraction commutative property. Okay, and that's it for this objective, so we'll see you in the next video.